All right, cool. We can wrap up our module 2 with a 4-bar linkage kind of design problem. So what kind of designs were you thinking about? I wanted to do kind of a walkthrough of like how I would approach it, but what kind of things were you thinking? This class is usually, this section, you guys are quieter, something, maybe because it's right before lunch, it's like hungry, harder to speak up. Or maybe section 3 is just in general, like, which one? Windshield wiper, okay. So for a windshield wiper, what would I care, what's something that I care about? Let's give ourselves like, go back to 0.25, just look at, oh. So let's say my boss tells me, build me a windshield wiper. Like I need something that washes this windshield. And I come back and say, this is your windshield wiper. What am I pointing at? Like, how do I actually make a case that this is good? Or if someone showed this and said, this is going to be our windshield wiper, why would you say, like, you're crazy? What kind of windshield are you using? Like, why are you doing it this way? What's good and bad about the design so far? Yeah.
All of the bars are like connected to each other, like straight. I guess like not straight, but they're like vents. They're all like vents together.
Yeah. Well, so in terms of like how this would work, so let's give ourselves like a little bit of so if I said like this is going to be my drive mechanism for the windshield wiper, this thing would be sitting under the hood. So I've got like a little motor down here. Really it should be like orange, right? Copper coils. And then attached up here is the actual like wiper mechanism. So wherever link 3 goes, that's where my windshield wiper is going to go. Kind of like that. Yeah.
I guess I'd say is like the range of motion for the third bar is a little limited.
Yeah. I mean, like what are we really like washing here? If we think about like, this is, I mean, I guess we've all been driving like this for the last few months with ice all over our windshield and like a little credit card window snapped out of it. But right now, all we have is this tiny little window of windshield wiping. Maybe that's okay for like a fighter jet, like if it was like a really small window or something. But even there, probably we want more. I don't know. I'm thinking like old school, like airplane, where it just had these tiny little cockpits. So really I want to make that orange line as big as I can. Maybe not like a full 180 degrees, but bigger. So what do I want to do? Yeah.
Maybe you extended the length of the first it might help with the range of motion.
Yeah, I could make that L1 bigger, right? Because if I make this blue circle bigger like that, now as it connects, it should increase like my max and my min location. Like I'm increasing how much I can do. That's a good start. Bigger is better, right? So right now we have like 1 and 1. Let's make it 0.8. Nice big drive arm, crank arm. Think we're good? Try something like that. Something happened. Now we have this change like that. Let's look at what the paths look like. Look at that. Now I've got big range of that theta 3. So it's going all the way from, let's look at kind of the actual values up there. Goes from 50 degrees all the way up to like 160 or something. So like 110 degrees of motion. And the fact that it's 50 and not 0, like we can always mount something on. Like it doesn't have to be exactly 0. You can try to do that if you want, like change where the dx and dy are mounted to like get it to 0, but you can always say like the range of motion is the important part in our first, like before we jump into CAD models and start designing this thing. Plugged in. So that's our first step. So we increase range of motion, things are looking good. Now, how fast is this thing moving? So we'll have, whoop, default is kind of our 10 radian per second, right? So when my drive arm is moving 10 radians per second, how many meters is a windshield wiper? It's like this long, right? Roughly. How many meters is that? 1, call it 1, right? So what's 1 meter per second? Or sorry, what's 1 meter times 40 radians per second? 40 radian, which is just 40 meters per second. Yeah, because a radian is a meter per meter, so now we have 40 meters per second. Is that fast or slow? How fast are we moving on our windshield? Seems fast. How many miles per hour is our windshield wiper flinging rain off of our windshield? Let's look it up. 40 meter per second. 90 miles an hour. Good? Seems a little crazy to like fling water off of your windshield at 90 miles an hour. Also, if any person is like trying to help and you accidentally turn the windshield wiper on, they'll like take their finger off. Probably like deteriorate the rubber pretty fast too. So things are moving a little too fast. But I can change that too, right? Like, let's just say my motor is moving too fast, so we're gonna reduce the drive rate down to like 1 radian per second. Just drive it 10 times slower. And we can do that. We got electric motors, we got gearboxes. Now we're down at 4 meters per second, which is more like 8 miles an hour, or what, 9 miles an hour, right? 10 times less. Much better. Now we have like a workable kind of system. So in terms of like wrapping up, if I'm like done, I'm happy, change things, I'm ready to go. I chose a geometry, so I can list out like what I chose for that. maybe my units aren't quite like meters, because right now if I had a 1 meter drive arm for these things, like maybe it's all centimeters, right? 1 centimeter or 3/4 centimeter, but yeah, to like put it inside my dashboard. Yeah.
Did you change your drive rate too?
I changed it to 1 so that, like that, this top drive rate says 1, and then this DA is 1 times 1s. I guess what I should have done to begin with is just call this like drive rate, so that whatever I say the drive rate is, just theta 1 dot is always that. So I list out like what I was trying to do, trying to create little gearbox for windshield wiper. This is my geometry that I did. There's paths, there's motion, like all that was kind of auto-generated once I did the first work. And the wrapping up is really the things that I learned along the way of, in order to get a big range of motion, so coming back up to like this path plot, I wanted that orange line to be as big as possible. And in order for that to happen, L1 had to be large, like in relation to L3, and that gave me a big like red curve, the max minus min, kind of what that range of that is, and that's my main like design parameter. Then the other thing that I learned was kind of like driving it at 10 radians per second was too fast because it was 90 miles an hour. Reduce it by a factor of 10. Now I'm talking 9 miles an hour, which is a little more like driver and operator friendly. And yeah, so the project here is kind of connecting how does this thing work, make that design, and then quantifying. As an engineer, you get paid for numbers, like telling stories through numbers. So that's really what you're doing here. Is like, I have some graphs, I chose some like design parameters. Why is it important? Like, what are the things that I should be looking at in those graphs? And in this case, we had 2 main things, right? Like range of motion and speed, like total speed of that windshield wiper. Sound cool? All right, I was talking a while. I want to check in and see what people are up to for like designs and questions, and see if we can wrap up that way. Any questions before that though? All right, cool. Let me check in. Bring notepad. How's it going? So many screens. Okay. Okay. Yeah. Oh, prosthetic arm. Do you think 4 bar? What would you do 4 bar for that?
No, I was
Yeah.
We looked at how the knee was.
Yeah, and the knee is definitely like 4 bar, and that helps with your gait. And your elbow. I don't think that one has like if you change it like in the same way, like it doesn't have like anterior posterior. Like like your elbow. One camera is dedicated. Yeah, your elbow has a little different because it has to support like the twisting, like the joints. Yeah. Are you biomed? Okay, it was. Yeah.
I like that.
But the other thing that comes up with, like, when you think about your arm motion is in ergonomics. So ergonomic design, a lot of things are 4-bar linkage ergonomic designs, where this is the connector arm, and this is your rocker arm, and then you have some kind of crane that you have to do. So you think about like how big can I make this crane? Because if it's like this now, and the range of motion is kind of broken versus really tiny, now it's hard to do. It's kind of like an optional crank that you gotta do so that your works. Yeah. Okay.
I looked at suspension, but I think like the safety sometimes figure out how
Oh, how the suspension works?
yeah,
Yeah.
to like but I might do that.
Okay.
Are you a mountain biker?
No,
We're on the car, so.
yeah. Yeah, in the car, there's a, like the front suspension usually, well, I mean, even the rear for like off-road vehicles, use a 4-bar. There's a kind of like, if your wheels over here, your axle goes out that way. And you can choose these two lines so that you could keep it parallel the whole time, or you have it cambered.
Yeah,
Yeah.
I think I've seen that. I just have to like do that.
Yeah. That's okay. Okay.
It's
Let it go.
oil result, so you have to have one of the links with the bars with small, and you have to make sure the small.
Okay.
The long ones.
More angles and
Back. The small location and the huge one. This was there's a lot to basically a lot of flight or independent as well. The hinges is just a path. So from one small location, I believe that because one of the bars was just busted, but they kept flying away up there. So basically, you have like a huge angle on both sides, and that small torque was allowed to apply torque for that small rotation like that. But some torque to, have like a smaller, but it's angle. Yeah.
you didn't import.
Like, it provides some like sufficient angle change where it's basically from the path of the hinges to move up and down. So pretty interesting, but also I like this, like, why I realized that if you have basically out of angle, like in a harmonic motion, that's the second one that basically provides a smooth motion, but also motion, but also you can kind of twist really well from it.
Okay.
So that's why I wanted to say that. Sorry.
No, that's okay. Yeah, because they're usually like cameras. Yeah. It's both push and
But you can,
yeah, and I think it usually uses camshaft because you kind of want like transition to like open and close, like you don't want it slowly opening. Yeah, so that one.
and what's it called? The can design is kind of different, right? It's kind of like but also basically one of the soccer arms is basically like not engaged while the other one is engaged. So basically, there's another kind of separate. Actually, two different things. Oh, two different things. One for the other as well. And they're all head sponsors, so.
That'll be a little different than four bar. Yeah. Are you thinking like trying to get rid of scam, just use a four bar? Yeah. So at least I would think you would want like sharp sort of angles, kind of go down. I don't know exactly how to like flip, switch like that, but might be able to play around.
I'm sure if you just like go back, I think it was. So then I would
That shape is kind of articulates how far the voucher push back, but also and this basically dictates the duration.
Yeah. Yeah. Oh, the platform. Yeah. Yeah. You get the since you opened it up. That's your so with SWAT, then it usually mainly like symbols kind of walk through the mainly. It's called
That's specifically what we call this friendship is so long that there's a lot of rocky couples which three snapping off. That's why they did it. They get very response all the time when
but now because we're thinking of like L1 as a frame, we need to limit its range.
Yeah, but I was also reading.
Like you can kind of zigzag it like this.
also
Yeah. And we might have to play around with like initials, yes, or angles. It's not. Because it could be the opposite section, if that makes sense. This is one solution, but this is another. Yeah, but we don't want to flip it to that one. Yeah. Yeah. So, I'm trying to think of just then what we need like two fixed positions and now this fixed position is changing. Well, in terms of like the driving, so this one's kind of like two different mechanisms. You have on this side of this thing, right? And on this side, a 4-bar package. Connector arm, L2, now L7 is just now because
One.
Well, no, I can see that.
Whatever angle, right?
So there's a language, culture, and then relationship.
So the second, this one, that right there, that thing is just here.
Yeah.
Check.
And that one's not like.
Oh, so it's the fixed position.
How exactly would that change, like, since it's in the middle of, since the X point's like in the middle of the bar, like, how does that?
That's sort of like in the same way that we're do the same thing, so we're actually
Film stuff.
yeah, so we're just creating how we're going to create it.
I was gonna do the niche, but I know it's in like my knowledge. That's supposed to have some schools.
Yeah. That was cool.
It's always trying to ACL, GCL, I'm just gonna stick with like. It's gonna be,
Yeah.
it's really nice, like, yeah, but also, but this is getting closer to the. Oh, so basically, like every time you do this, yeah, but yeah, really,
Yeah. At least like. Like if we start with like a simple.
We was adjusting, so
This top and that bottom are gonna be able to just nice round numbers. L1 and L3, like you get
I mean, you are.
Yeah. That one.
Yeah, I was like messing around with myself with this. What's your shitty? That's just something I was oh, that's what this is. If you change this, pretty much all it does is like, you change like the position. It's like, it's at 10, it's like,
That's that'll just. But I do think
I need to make the timing blocks. I'm going to make a visual calendar.
No, yeah, because instead of it being, you were using
Yeah, it takes like an hour of like, just don't pay attention.
instead of falling from
No, just Where's like, these are.
it's not actually changing for whatever reason. It's just changing the market.
Like, society, and then maybe five. So I just finished my whole.
But changing the numbers. It's just gonna change. It's just gonna change it. If you have a good now, read where ours is going to stop.
Really, we want to be as close to
I was playing arts and basically, I don't know. How would you go? And then I just have to. Mine's all. Because they messed it up. They messed it up. Two of the classes that we're supposed to. They're gonna try to put it online to the students. Apparently, up to one section is online, not now. Why is it online?
Oh, good.
So it's hybrid, so once you my earth science, it's hybrid, you show us once a year for like an hour and a half. All the lectures are online, I'll show you what it looks like. No, it's just a discussion, but you have to visit. No, it's just all, like you just have to share that. Oh, there's a group
Yeah, well, the issue with graph is that when all these should be full circles, like, this one cuts off versus that one. Back and forth, when it should be equal to it. So I'm just having trouble finding where I need to fix that.
So you basically
Yeah. Now, this one continues out.
and then you just have to answer questions where it was. It's
So
just
sometimes
not
it turns
hard,
into
and
maybe that green on the top and the bottom. So I'm assuming it has to be, you can try,
and 4 hours.
like somewhere with like these,
Like blocked out time.
Well, I think with that, like, DX, just try making that, right now it's equal to, try making it like 0.99, like, not quite that one. Try making it everywhere.
so that's making it a little bit bigger is what gets it unstuck.
Yeah, and like in practice, we can make them all, we can make the distance between the two equal to that connector. And there's gonna be momentum that'll bring, it'll keep moving all together.
Cause I figured it just, based on the dimensions, that it would have to be equal, like that distance from,
Yeah, yeah.
right?
And you can make it like even smaller, like right now, it's that big, that big.
Okay, that makes a lot of sense. So it's like,
Like 0, 0, 5.
So when does that? So you're done.
Okay.
Yeah, and this, the closer it gets, the smaller.
It's like going out and like 2 seniors and everything. And
So
then
just like keep
back
playing.
to
Yeah.
What's 6 years and next year? We'll have to pay this.
Getting there like every single time.
Under the company, and like, every single year. It's just like, like it's not.
This whole thing, like,
Once 6 years.
So the more, the bigger you make DY, the further up that, point C will be. Like right now, we're in that right hand side animation. DY is yeah, like DY is probably like 20 centimeters right now.
Go with that, like tilt everything over.
Yeah. Yeah. Yeah, nice.
Skip that. Question.
Yep.
Basically, if this class was just both satisfy my C2, my CA, my C2 or
Yeah, that's our
my
main
double drive and also my additional science
Yeah.
I would personally
Cause
consider
that big right hand side.
CLHS
So,
in life science. So it's speech hearing, speech, language, and hearing science.
it's kind of like a mirror.
So I'm like, this sounds like it would work.
Like the more, I guess the less
So
ones that I had.
it does.
Cause like I first started all this like last year, like about it. So it's here now, so we have two kind of bars, like now. We're just gonna get an active bar, it has to take one. Like, right?
I just like, I need something to open and just go.
Yeah.
I was in like, yeah, I was like that. Also, my mother like that.
It's just a
Catch me. I write that.
Oh, 2310.
Just.
Yeah, it's still long.
Right now.
Yeah.
So,
You should have learned when I was here. Oil pump jacks, windshield wipers. Yeah.
I love how direct it's like, I just found like other books.
Yeah, go for so I did. Rubber rubbing on.
Yeah, but don't.
Probably more than like.
It was me and
5 or 6 miles an hour.
You'll shoot the same
They just
motion,
said
don't
even
shoot
the
out
time
of
of
the
your
ice
time.
And then that's where you're actually saying, like, what did you do? Yeah, this is when you chose that action. Is everything meters?
So that, I like that, I told you that. I don't think you're
Yeah. So that's gonna say angle 1, right? Start at 0. And go just
Like it was so I just felt like the second word.
yeah, because once it gets to there, it's just gonna start. Yeah, it's gonna start over. You're showing the full range of motion.
Yeah.
You don't have to. Yeah.
I told you, I'm gonna make this out on a document and give it
Oh, really?
he doesn't know what that's right.
I mean,
Yeah.
Looks like a model, but it's still on. Oh, yeah, there you go.
Yeah.
And there they took the double and more for it, and
Which thing is
And I go-
up in arms versus.
you get to go around the part of the. It's a good explanation, but it doesn't make sense. Like, you know, talking to Andy about it. Oh, that's really.
So like, So the head and the arm is connected by
I love it. Just like she has like so much
okay.
energy, like
The arm.
our energy really matches, and so I think it's gonna be perfect.
135 degrees.
She's living with her friends and stuff.
I can't see.
It was in the mall, they had the bounce house thing too, and
I inserted it, so, and I just did hashtag.
Yeah, that's what I'm saying.
Say you get down to 4 yeah. At least if you want to make sure that the 0 angle is which is I think he's the great setup, but it was just I got this with it. Usually it's like cosine plus. That one, I think it would say 0. This one would be 0. That one, probably like, yeah, less than 3 radians, and then this one close to 3, which makes sense.
I was just thinking about having it being a part of, a robotic some component and
Cool.
having, I just bring it some value. And this is, I guess, like, I don't know if it's a starting point.
Could be, depends on what your robot is trying to do. Like, what do you want the robot on to do?
I don't know exactly. I guess, like, like, well, I mean, what would I exactly, like, what is this like exactly? It seems like range of motion. Like, you're fucking alive. Yeah.
I mean, right now, it looks like you might have some kinematic locking at some point. Like, that's why it's like flipping.
Well, I was here
so much, and you're getting this warning. Oh, but they're all connected in the same spot.
Yeah. Oh, that's it. Is that it? Like basically, I know that this is like.
So really, what you're saying is like this.
Oh.
Everything should just move in a circle.
Oh, okay.
Because you have a.
Oh, okay. Okay.
That's what it should do, at least.
Yeah. Okay.
But you created a triangle that can't connect back to itself. So you end up with random fluctuations.
Okay, that makes sense.
Yeah.
So.
How's it going?
I'm surprised they got the order right because like there was like 4 of us in the car, so we had like 4 burgers, like 3 chicken, there's no sandwiches, fries, nuggets. They got all that shit right.
Yeah, so you have to land. That's all I need.
God's where they go.
I've heard the other one.
This is genuine. Yeah.
Okay. I was looking at like, so these are not like, just to be able to. And you actually ask questions. And we were talking about.
Sorry.
You know what I mean? It's not work. It's not.
So I like to look at it as if you put everything in one spot. So if you change this to
They let me.
like now,
They let me
or it just turns into text.
I had it on Friday, and then so what I was doing was ew. My grandma.
Yeah, you ran into this whole place and went on like
That doesn't.
Yeah.
so there's a, if there was no, like if these things were massless, as it when all the equals are 0, there's a chance of the boat could tilt. You know what? Now, this one flings everybody out.
Oh, I got it.
Yeah.
Yeah, right. Oh, they will.
But in practice, it doesn't happen. I don't worry about, like, you can mention it, so like, mention it, it's called a kinematic.
You're the one that.
Yeah, in practice, like, moving this way, that just. You would need a lot of torque.
But the way that like the significance change cannot be done in these days. Because I think that's what my friends about the car that drive every time they do it. That cannot be a short. Because my friend lives with like 3 other guys and I don't even. So